Hello and welcome to Technical Room Session 4 at today's buildingSMART International Standards Summit in Montreal. Thanks for joining. My name is John Proctor and I will moderate this session for you. Details of today's session are on the screen. I will hand over in a moment to Greg, who will introduce the session, and then Leif will be presenting to us. Before I do hand over, I just want to remind you this is a hybrid event, so if you're online, your microphones are muted, and please raise any comments or questions in the chat in the Hopin platform, and we will raise them. Thanks to Jan for letting us know that you can see this session is up and running. I also need to bring to your attention information on the following slide. buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and that standards that are developed do not favour any particular provider but are open, non-binding and accessible to all. Please take note of our antitrust code of conduct. Thank you. I'm going to pass to Greg.
Thank you. So just quickly before Leif goes on, so this is the last presentation we'll have of the day. I need to thank Leif always because I actually took over managing the technical room before Dennis co-chaired it with me quite a few years ago. So after this presentation, what we're depending on the mood, we'll either solicit some feedback on how to make next steps, or we will solicit interest, call it a day, and look for any of you that are interested in participating in sort of moving this IFC5 forward. So that's it for now. Leif, it's all yours.
Okay, thank you. I changed the topic of the presentation in the last minute because I had as a topic ECS context, but actually this presentation is more about the kind of general future and role of open standards in general and IFC in particular in the AEC industry and how that should evolve. So from here, okay, there. Thanks. So first, a few words about myself. I'm a software guy in and out. I have been working in the software industry for 43 years now for the same company, not so very common in the IT industry. And I have been doing every job there is to do in the software industry, both technical and commercial. And have been now Trimble's standardization expert lead, whatever you want to call it, about 10 years, and represented Trimble in buildingSMART, ISO, and OGC. Of my career, I have worked about half in geospatial and half in BIM. So I have done both, and I have been working with model-based software for more than 30 years, 35 years. And when I say model-based, because that's used a lot of model-based here, what I mean with model-based is that when you do your information model design and create the information model, you go actually directly to the reality, not to the papers. The traditional way of IT is that you look first, how has things been done on documents and papers, and then you model that into your software and make your software according to that. But I mean, when I say model-based, I mean that you go straight to the reality and do the modeling already from the beginning on the terms and opportunities and possibilities you have with electronic processing, and don't go the route via the paper document-based representation which was used before. So a little backdrop to what I'm going to talk about. As the BIM ambassador, I can define BIM, and my definition of BIM that it's just the transition from human readable documents to machine readable data, period. Nothing else, nothing more, nothing less. And that's has a big implications. And one of those implications is that in the document-based world, presentation and content are totally bundled. So it's the creator of information who also decides how it's going to be consumed, how it's presented, and how you can use it. Whereas now in the digital-based world, model-based world, it's the consumer that can himself decide how he's going to consume data. I'm quite pleased that I saw, by the way, I have been talking about consuming data for years, and now I saw quite a few people here also talking about data consumption. So that's a big change from the document-based world, which comes with the BIM. And that leads to that focus in BIM software is shifting from data creation to data consumption. And today, most of the software is for data creation, and that's going to change so that most will be for consumption, and the creation will continue to grow. So there will be an explosion in the data consumption software. Then a bit back to the kind of problems that the fundamental idea in BIM and in IFC has been that it's a single database with a single instance that many people use and edit, and that's very much reflected in the structure of IFC and how IFC is defined. But that market is more and more realizing that this is not possible. My motto is one size does not fit all, and we need different kinds of ways to store the data, to share the data, different data. So we need a multitude of ways to store data. But there is really no generally accepted concept on how that's going to be done. And when I talk about this, I mean very often talk about this data consumption. And when you get an IFC file, what do you do with it? That's pretty unclear, at least if we take the real construction workflow. You have some points where it's very clear what you do with the IFC when it goes to facility management or some other places, but during the main part of the construction process, it's not at all clear what IFC, what the incoming data is used for, and how you consume it and what you do. So I'm putting here, I have done this about same presentation also in Norway last week, or a couple of weeks ago in the ECPTM conference. And I have put it also now as a candidate for the InfraBIM 23, but haven't heard yet. And as a kind of remedy for that problem, I'm putting forward something I call productivity BIM. So it's becoming more and more so that people perceive BIM as a burden on their job, because they mostly don't do it for themselves. They do it for collaboration and for others. And what I'm putting forward is that the prime reason for modeling and using digital should be to make your own operation more effective and more increase the productivity of yourself. And the collaboration aspect comes more or less as collateral damage, so that you get the sort of collaboration as a side product. And that's what has happened with Tekla Structures. So Tekla Structures is good proof that this is possible, and it has already been done. And that has some implications, because now when you model for yourself, because always the quality of modeling and models is a big issue. And when you model for yourself and for your own use, you can't take shortcuts. You have to model it properly, because the things are going to be done according to what you have modeled. So you have to do it properly, which leads to that the models are of good quality. And that Tekla Structures models generally in the market have a reputation of being of good quality. So that's a very important side effect of this. And of course, the main target of BIM should be to increase productivity. And actually, Leon van Berlo was at the same conference, and we were talking about the same things. His topic, he had a keynote as well, I had a keynote, and his keynote was, don't forget about import. So I was talking about data consumption and he about import, so we were on the same note with him very, very much. Modeling reality, just preparing for the next slide, that typically the reality is too complex to model with current technology and also foreseeable technology. So we have to base models on abstractions, and typically, and to the abstraction concept you have that is made for a purpose. You don't have a generic abstraction. It's always for a purpose, and that's why we need different type types of object for different tasks and purposes and what we are doing. And this I was talking already in the earlier session that, and this is a very simplified picture, but you have very, very different representations for different tasks, even within the same discipline. So if you take MEP, for instance, if you have properly modeling MEP, you need first to have a requirement model, which is just information attached on spaces or linked to spaces. Then you need to design what is your system areas, what kind of systems you have. Then you need to start put out spaces for the equipment, which equipment you have, and those are all separate models. And you need to have them persistently and maintained all the time, because that's I've discussed with American MEP contractors, and it's a huge problem for them because the designer makes some kind of MEP model, but when it goes to the contractor, they model it again because the MEP designer's model is not for fabrication with that contractor's methods and systems. So they model it again, and it's a nightmare now when something changes in the designer's model. It's totally manual work to put in those changes into the contractor's model, and the workflow there is totally broken still. And that's this approach which I have remedies also that problem that you get the real information flow. This is a simple example I use very often, that typically for the architect, a slab for a floor in the building might be just one object. For the engineer, it might be 5, 10, 20 objects. But for the detailer, it might be 10, 20,000 objects. And it's still the same physical thing. And it's not easy that you would have one-to-many relationship. You have many-to-many, because the structure might be quite different, that the architect has modeled the walls by floor, but the engineer wants to have one object that goes through 10 floors. So part of that is parts of the architect's many objects. So this is a pretty, if we want to have a real model-based workflow, this has to be solved, how to manage that, because with the detailer's view, you can't do the architect's job and vice versa. You need different representations, and it's really different. It's not just some small details that are different. It's the whole object structure is totally different. And this actually goes for all disciplines where you have this hierarchy that you kind of, or let's say sequence of different representations, that you go from more conceptual to more physical in many steps typically. It's not just 1 or 2 steps. It's 3, 4, 5 steps typically that you have to go through to get to the final physical. And so I have used Greg's slides. We have discussed them, so I don't put them more. The picture of the entity, we have discussed that also. All concept by many names. But the concept I'm putting for how to make that productivity BIM work and kind of deliver on the original BIM promises, that you don't have to re-enter data. You have to that you can use data which was created in the previous steps and phases, and for that I push this federation and publishing-based information architecture, and that just means simply that the application data is totally the native data which the application creates, maintains, and owns. Owning very important here, because the ownership of data is always a big deal. And the data you get from others, which you use to do your work, you keep them separately. You have a total firewall between them. You don't mix them in storage-wise. You mix them only with application functionality. I'm coming to that a bit more later on. And that's this can be done with it needs change into the software architecture. So that's something which I have also been pushing for a long time, is this multi-kernel software architecture. I'm coming more to that. But then also the software usage paradigm needs to change, because if we want to realize this productivity increase platform and increase automation or promise of better productivity, we need to change software so that it's more driven by the data it gets from others. So the software is data driven, whereas today all softwares almost are more or less totally human driven. So it's everything is based on human actions. Humans have to do everything, and then they can use the data they get from others to small support. And that direction needs to change so that the software can better and more autonomously and automatically use the data it gets from other parties. And have the really workflow and information flow go. And this process algorithm method and data driven. So TechnoStructures also does this partly already. Then another thing with Autodesk talked also about native data and the kind of native, how native data is stored and managed is changing quite rapidly. So it's becoming less and less static data, more and more algorithms, methods, code, machine learning, AI, and becoming more intelligent in short, and less things that you store in static data. The kind of content and more of the content is on the process method side and less on the static side. But this kind of data is quite hard to consume because it's complex. If we think IFC is complex, this parametric intelligence data is much more complex and much harder to understand and harder to use and consume in anything. So that's why the consumption. This is one other reason why consumption should move to snapshots in open formats, which you then publish and publish them so that with the publishing concept, so that when you give it somebody else, they can't change it. They have to use it as it is. If they need to change it, they need to ask for a change from the owner of that data. And I'm one of the founders of BCF, and this was one of the big use cases of BCF. If you need a change to somebody else's data, you don't go and change it, you ask for the change using BCF. And it's prepared so that you can have even semantic change requests. So that if you need more space in your ceiling, you don't say lower the ceiling or raise the roof, you say I need more space. And then the owner of the issue needs to make the solution, how that's going to be solved. And BCF supports that you can have back and forth discussion that is this solution or how, and even have other parties with it. So that's this is again about this round trip. That round tripping is not possible and not a good thing. So you do in a way you do round tripping this, but not with the same data. You use different data for the round trip than just having the same data go back and forth. And this multi-kernel software architecture, the main thing here is that it can consume data in several schemas simultaneously. So it takes this also when you have the BIM GIS integration question, instead of trying to do that statically, you leverage that functionality to software application functionality and do it on the fly, which can be even in the same software for different use cases and different purposes. You can have different integrations of the same data, and you integrate then both your native data and the data you have gotten from others, which are stored differently. And there I have a small schematic of this. This is very conceptual schematic, but of course every software, well, most softwares have their native data storage where you keep the data you own, change, edit, create, and then you use standard data, which you can use either direct the standard schemas or data in standard schemas or through some kind of abstractions. And in Trimble, we have an abstraction method. It's called TrimBim. Don't know if you've heard of it, but TrimBim is exactly this abstraction layer which abstracts the standard data to be more closer or easier to consume for the application layer. but it doesn't cover all cases. So that's why you always have also the option to use the standard data in its native, the native standard data in its access. So it gives the freedom to the software developer to how to use the data. And then this workflow, how I envision it to happen is that instead of you going around and if you are, this is the engineer down and the architect's lab here, instead of going click, 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 there is application functionality in the software that knows the fundamental things of how to do that first step in the phase. So create from the architect's objects, create the engineer's objects. And it can also do this and create relationships. So when you have done it, and this is where I see the first and most important role of linked data is to link together these different representations so that you can have changing flowing downstream, or actually it's not up or down, it's a network that will become of this, and change requests going upstream. And if the architect changes something, the engineer can directly know which his objects are affected by the potentially affected, at least by the architect's changes. And with this structure and idea, you really can deliver on the BIM promise that you don't have to re-enter data, that you have a real model-based workflow. You don't need drawings, and you don't need so much manual operation when you do create your own objects. Of course, it can't handle all cases, so some things can be done more automatically, some less, and of course, this will be machine learning is a big promise here. We already are employing these in structures so that you have a machine learning-based automation when creating your objects. And the important part here is this information management ownership data, that nobody else can go and change your objects, but they are still part of the overall system and data. So this is a slide I made almost 15 years ago in Vietnam, of all places, and this is system architecture is clearly now going in this direction. So we will have these existing desktop applications still for a long time to come, but all BIM vendors now have these cloud-based services, Trimble Connect, Autodesk 360, Nemetschek BIM Plus. Everybody have them, and they are developed heavily. They're kind of focus, I would claim that for most vendors, focus of development is here. And then these are going to be platforms for the new data consumption software, which is going to be developed. And that's where the bulk of new development will be. So this role, I like to call them publishing platforms instead of CDEs, but today the common term for them is CDE, and I'm fine with that. But I don't think about this common because my prediction, and it's the clear signs that the competition between the different software vendors will happen in these interfaces. So there will be a baseline here, which is standard-based, and these open CDEs, this is already being developed and is partly in use. But this means that most, in any major project, all of these platforms, all of these different CDEs are going to be in use, which means that these CDEs have to be interoperable and interoperate. This concept also applies for FM. So it's just a model-based FM system is a category of software which is still completely missing. There are none really that the fundamental basis objects of the FM system would be spaces, because the purpose of buildings is to provide spaces. So an FM system's fundamental concept should be spaces. And then, but this concept works that you take the incoming IFC, you have different representations of spaces, you pick those and which you create, which you need, and then you create a native database where you store those spaces and manage those spaces, use them for rentals, cleaning, whatever. and also if you need GIS data, you need to take that. And you have all your live data, living data, which you need to update, you have here. And if you need then to do renovations or whatever, you produce new IFCs from there with the current situation. And people say that IFC is a bit difficult to edit. Well, my response to that is that concrete is much harder. So compared with the concrete, the IFC is pretty easy to, and you can create objects from the IFC. If your software is working in this way, you can create your native objects, which you do. And then, of course, when you do renovations and changes, you don't do the same things and operations you do when you do design new buildings. So eventually you need different software for renovations than you do for new buildings, because the actions you do are so different for existing buildings than for new buildings. So this federation concept also works totally for the FM and operation phase of the building. Well, current software, more automation, incoming data, and my mission, and why I'm 67 now, I'm still working here. So my mission and vision is to leverage the role of open standards in the AEC industry. My vision is that the bulk of consumption of data happens in the open schemas, so that the role, that's the kind of mainline way of consuming data, is using it directly in the open standard schemas, not converting it to any native. You only convert it to native if you need to change it in a significant way. With this ECS, you can add properties and make kind of these amendments and easier without editing, and that you can do directly to those standard-based data. But then if you need to make more radical changes, then you have to create your new native objects to do those radical changes and radical jobs for it. So I really believe in open standards, and I have been working with them for a long time. And so I have no products from Apple as long as they keep. I have no products. I won't buy a Tesla as long as they go for their closed approach. I'm an open standard guy, and really believe in the possibilities and opportunities that open standards can give to the AEC market. Then we have been. I'm a big proponent of linked data also, as I see a linked data for the main tool, and you can also implement this partially, so you don't have to put everything as linked data immediately. So the first application I see for linked data is this linking the different representations together, because linked data enables that you can have the link set separate from the either data set. They are separated. They don't need to be bundled, because I like unbundling, as you might have guessed. But we have worked on this already for a long time. So we have almost 10 years. We have had many research projects, and actually the creation of IFC OWL was to a large part funded from our project. We got 2-3 million, not more, almost 5 million euros total funding for these projects that we have had during the 10 years from the Finnish government. And a significant part of that was used to create IFC OWL. So, and there we have again, to manage this type of instance, results of the research was that linking is the best way that you can do it by comparing. This is mainly kind of the clash detection type of things that you compare two models, and then you get some kind of report and result of what it was. You can try to fuse it into a single data model. Not very good rigid control, and the best is linking with the linked data technologies to do that. And we have done quite a lot of research on how to do in different applications, different databases linked together, and what type of functionalities we can have. And there's a summary. I think these slides I won't read them here now. And there is still quite a lot of material. I think I don't have, but if you want the links, I can publish the links to the results of those projects. So that was about it. Or did I have any? No, I have no. I had missed one slide of this easier. Okay,
thank you, Leif.
Thank you.
Let's see if there's any questions. Yeah, thank you. Thank you very much, Leif. Great presentation. Are there any questions or comments that anyone wants to raise in the room? Yeah, sure. Go to that one. Yeah, thank you.
So there's a difference between knowing where we're going to get and knowing when we're going to get there. We talked a little bit about the transition from a human-driven process to a data-driven process, and whether there's a tipping point. Is there a way to build human-driven tools on top of a platform that will allow us to go to a data-driven? How do you see that transition going?
Well, there is one thing how I see and one thing how I hope, and they are a bit different. But the transition is clearly those platforms. Well, as Devon showed, there are human interfaces. That's already start to be daily things that are happening daily. So that's already ongoing. But I know that we are doing, and I know that all the vendors are doing research on how to automate more, get the more. So the crucial point is the automation, how to get that going really. And hard to say, a few years, it's not going to be this kind of sharp turn. So what I'm promoting and here is kind of the direction, that in which direction we should go, because it's impossible to change that abruptly. And but the nice thing with open standards is that it gives a more level playing field for startups and new smaller software vendors. You don't need to have that huge, and there you have two steps. You have kind of, because all the current big vendors are offering APIs and possibilities to build on their platforms, but you can also build on your own, and there are also independent already CDE platforms on top of which you can build applications. So the threshold to kind of enter the market is lowering. With the more we use open standards, the easier it is for new players to enter the market. And competition is good. So it's also good for the kind of old traditional players, keeps them awake. Monopoly is never good. I'm totally for market economy.
We've also got Greg and Devon back in the feed as well. So if anyone's got any questions for Greg or Devon as well as Leif, then please do raise them.
Yes, I have a question. I like the link data promotion approach. You mentioned IFC hour. One of the main principles for backward compatibility. That means that the IFC hour was maybe different than which we have.
You can slightly say ugly. It was not optimal. Let's say that it was not optimal.
Yes, it's not optimal. This month we approached the semantic naming standard that we could use actually to do a better job for a linked data variant of IFC, for instance. Do you see any potential? It's not much discussed these days, and I always try to promote it, of course, but we could do maybe an IFC model to say like that.
Yeah.
Before you respond,
Well, not much to comment. Yes. Yeah, I would support that very much because it was the first attempt, and still I don't think again here you can't go over to linked data like in one go. You have to introduce it bit by bit, and my suggestion that this linking could be the first bit you introduce, and you could make limited endpoints where you can access a kind of query the CDEs and the devices for object or the databases for object, but they would be returned as IFC snippets. So I don't see much point in expressing geometry in linked data. You can do it, but I see initially at least the role as IFC snippets there. And that's why I'm talking so much about that. The IFC, next generation IFC should be ready to use as snippets so that you can have anything from one parameter, one property set of one object to the whole building, but it's your choice what you have in the data set. And I don't like talking about models there. I would promote, because the geospatial community is totally talking about data sets. And I think the BIM community should go the same way. We won't ever exchange whole building models in any phase. It will always be bits and pieces, and probably more and more bits and pieces than now. Say online question, but it went.
Let's see if we've got an online question. Any other questions in the room, or comments or thoughts? And Greg and Devon have rejoined us, so if they have anything they want to add as well, then please do so. There is a question in the room.
Yeah. Is it a chance to show something?
You can, yeah.
Yeah. I mean, our main topic here is to learn what we should do in the future for IFC. And I want to borrow one of your slides. And it was like, we have here databases, vendor-driven, probably locked. We have here individual applications, mainly feeding data.
Feeding more
And then we have others over here receiving data.
Yeah, or let's say it's a bigger arrow in this way and smaller arrow.
I oversimplify.
Yeah.
Okay, so my understanding so far was, and I wasn't quite sure about your observations, because I thought this one more or less is IFC as we have for the initial feeding. Of course, what we do not have are the updates. This update process.
But updating versions has its place, because as I said earlier, my main aim is that the IFC to be contract and law legal compatible, and for that you need snapshots.
Yeah.
Digital design snapshots. So, but probably we need both.
Okay, good. So that was the one thing. I saw the other one, it was IFC, and it was, let's say, between two of those.
Yeah.
Let's say database conversations. Okay, that's clear. But what I was also somehow expecting, and I'm not quite sure whether this is not our goal, is have something here, which I would call maybe an IFC API. That's just for now.
Yeah, it's not in the picture, but I said that
because when you take your small applications here, I think it's better to access one API, because then you can also access this one instead of being specific to all of those.
Yeah, that's what I said, that there will be a baseline standard for this API, but all the vendors will expand that for their own internal use and also for third party.
Okay.
So I totally agree. There needs to be a part of this that it's standard for the small vendors.
Okay, and then of course I'm still convinced that we will have bulk data exchanges, but mainly for archiving purposes. So I believe there's one archiving layer here, where you have snapshots, and you will still have full data sets, gigabytes of data sets for archiving purposes.
Well, this can handle gigabytes. So you can make it from there as well.
Yeah, but normally you want to have it not in a vendor-controlled environment, but in a neutral environment. Like
but this can be neutral.
Okay. But maybe also general the question, are these main topics? And when we talk about ECS today and so on, we are talking about this one, this is kind of updating or having only communicating changes here. I mean, where we are positioning our functional goal. Maybe that's a question to the team.
Well, I guess the only one I would look at that is, are we sending any different data in any of those things? And if they're all the same data sets, sorry, if the purpose of those connections is database to database, app to database, or web app to database, and desktop app to database. This strikes me as the same data. So you should be sort of crafting an API that maybe there's variations or they're actually very similar. I don't necessarily see anything different there.
And my other question was, will we have one, let's say, one standard representation IFC fitting all of this?
Well,
Hopefully no.
Well, you do, like, it does open up the question, just like IFC today can be represented in different ways. We see it in STEP all the time.
We have different serializations.
Right.
It's the same scheme.
ECS, yeah, that's a better way to see it. Different serialization, the same schema.
But I don't see these kind of directly being about IFC. I see these as kind of making these easy and feasible to implement, these kind of requirements for the next phase of next gen IFC. So these doesn't directly affect what the IFC is. These are things around. So this is OpenCDE. This is also, these are all probably OpenCDE questions. So more API and service type of specifications, but making these reliable, easy to implement are requirements for next gen IFC.
So just to finish up Thomas's question, the ECS approach is just as reproducible in other serialization, certainly. Like the place that, I don't know if you strictly call it ECS, but this USD format that's becoming quite popular in the sort of the entertainment plus metaverse discussions. That's certainly a rich enough way to model such the same information. So I'm not necessarily, I don't think we're saying that there's one flavor. Again, I think it's a modeling paradigm, and we have to sort of adopt that or modernize it so it fits with the modern architectures, I suppose.
Yeah, and one thing which follows kind of as requirement of this is modularization of IFC, so that it's not that one huge schema. So that I think that's the most stripping of these requirements to have this unnecessary data, like side project. If you don't need them, they shouldn't be there. Now we have to invent there's some garbage because there is no way of sharing that data in a reasonable way. That needs to be published separately, maybe even in a separate package, and it could be a separate submodel. So
you don't like models?
Information model, yeah, IFC is information model, but not models of buildings or things. I wouldn't call those models. Those are called data sets according to the information. And that's how geospatial community does it. Information model is information model. They don't talk about models then when you model something in the real world. That's a data set.
Let's go, Dennis. Do you want to come up here so we don't have
Okay, you had 10 bullet points from him.
Yeah.
One of them was
David.
Yes, David. That the objects don't need to be in the, what do you want to call it? I'm going to call it the scene graph in order, right? If you have local transformations of objects, how do you do that? So if you model a beam and it's local, the correct one answer is you have some global coordinate system and everything is positioned globally, right? Is there another answer? How you could have an object with this local coordinate system, pull that out and not have it like sitting on my, is there that question about sort of positioning the scene in a, what I call scene graph? When you start going to partial models, this seems to be one of the things that doesn't have that.
Well, so just for everyone in mind, the question was, if you have partial models, how do you
Globally position?
globally position
They
them?
have local, they're defined as local coordinates.
If they're defined in equal coordinates. Sorry to move around here.
I can give some thoughts on that. I'm not sure the total answer. One of them is that this only applies to the geometry component, right? So it's specific within that. And I know that within spec levels in some discussions recently, because as they're tying into Unity, in Unity there's an explicit scene graph, and there's a whole area that's instantiating one piece of geometry a million times. And so within Blender and within Unity, there's this idea of every object is placed within a local coordinate system. So I think we can definitely, when we're discussing the geometry system for FC5, talk about that, right? Here's an object in a local coordinate system. Where does that transformation sit?
Right. Because today it sits in the scene graph, right?
Right, and you could, in a geometry component, you could just have a local coordinate system.
You can have,
defined.
yeah, you have
Local
to,
system. There's a
you have to globalize at the object level.
So you could do that. Now, if we're talking about making an edit to a geometry, to some property that's not geometric, well, I have access to the plumbing parameter components, right? And I can change those in local, like that. That's not like everybody else doesn't need to think about that anymore, so to speak.
One of the things, I'm not saying it's the answer, but it's something to look towards is, so the USD context, they have a very similar idea where you call it a stage, is where you put the stuff.
Yeah.
And then you can do things on the stage. So in this context, maybe maybe you could say something like, well, I can have the stage has a transform that can position all these things from their local context.
And maybe geometry is only one of the things that, I don't know if there's, I just don't know other things in IFC that have this kind of state that gets propagated down the tree, if there's other things like that, and if there are, what do you do about it? I mean, maybe there's a meta problem to the geometry. I know how much information do you put on the graph itself? The part child
space hierarchy at least is in the same way dependent, so that you kind of build up.
Right, and one answer is when I pull something off and ship it, I gotta, before I ship it, I gotta package all that up and stick it on the object somewhere, send it out, and then Lord knows what happens when you take it back in and try to pop it in another graph. So
but
there are problems with that.
The positioning in IFC currently is a nightmare.
Well,
And there are far too many errors. And the bad thing is that quite often now the error can be just a few millimeters, where you have things in wrong places. And that's bad, that's really bad. Those
or if you
errors
just,
are
again,
hard to detect and can be very expensive.
that there's aspects of the objects that are in the relational graph itself, not on the object. What happens when you take it out of the graph? I don't know if there's other stuff that I see that has that.
That's one of the reasons why IFC is not editable, because that's not specified anywhere. So we have this normalization that many objects have the same data. So and say even objects so that the coordinates can be normalized. So you don't know if you change that coordinate, what happens? You don't know. And at least you might know what happens, but you don't know what was the intention. Was that normalization just to reduce the file size, or was it that they actually need to be in the same coordinates? And that's not specified anywhere. So that makes that IFC is not editable.
And I think there's another idea from the ECS paradigm, in that rather than the object owning all the parameters, the system owns the parameters of its corresponding component. So
I guess that's what we're saying.
all the geometry is then dealt with, within one data set with one author. All that geometry is owned by the geometry system. So if there's changes and things affect things that's there. And
So in other words, the stuff you say system to me is the graph.
No, this is actually a thing that keeps it synchronized. This is what's like this is where we're back to the USD. Sorry, the comment was about Dennis was saying graph. So this is actually the thing that has one responsibility, not a whole responsibility.
It's the assembly.
Well, no, the system part is literally like, you think about it, where this comes from. It's like I can have one developer write a piece of software that only makes sure we have consistency in location and geometry. Somebody else can do bananas. But I do want to be cognizant. We have people online. This conversation's hard to follow. So I don't know, Greg or Devin, any comments, points, questions? Otherwise, you're welcome to stick around, but at the same time, might be hard to follow.
Yep. Tracking so far. Thanks.
Yep, same here.
Maybe one more question also. But I just, so, maybe that was really related question. Also conceptually, would there be any kind of dependencies between components? Or is it by design meant to be that there should be no dependencies?
Well, what's an example?
Yeah, for example, we had this kind of positioning system, like local coordinates, and I have to follow, let's say, the spatial tree and all that to get the most one or I don't know, space boundary relationships. You probably have the geometry dependent on other associations between the unit model store, the geometry of the space, and so on. I think all these kind of, let's say, interdependencies. I mean, when I read the theory, I think the best is we shouldn't have it. But when I look into engineering problems, I think they are not.
I think it's yes and no. I can give the guaranteed correct answer.
Yeah.
So in the world of games, where this comes from, right? You've got a motion system that takes care of moving people and changing their position. So I want my player to move. I just add a component that says move me. The system takes care of that. So one system in our world might be a costing system, right? There's a component that is costing. There's a costing system that comes and generates a takeoff, generates a cost estimate, and all that. Now, in one situation, that component thing, the costing system doesn't need to look at anything else. All the information it needs for the takeoff is in the costing component. So in terms of using the data, you can just pick the components that matter to you and give a report. In terms of what's different in our industry versus the game industry, running of the games, like the game industry, and how game operates, is that actually, yeah, some person makes a decision, and then someone else makes a decision based on that, and someone else makes a decision based on that. So for a structural engineer, to add on the structural engineering property component, yeah, that data does depend on the architectural component, right? It's upstream of it. So there is a sequential flow, which at the moment is implicit in the whole industry, right? It's not explicitly modeled. So there is that, but in terms of understanding it and understanding things, you should be able to look at one component and understand that there's a system, there's certain things you can know just with that component in isolation.
Or another example, where my understanding is that the entities are not typed anymore. I mean, they only have an ID, they are very abstract. Just in simple thing, having a material component on a space seems to be unlogical if the space doesn't have, let's say, volume or physical experience. Is there anything to encode this, or is it just up to the system to understand? It's a little bit, quite often you're dealing with data models to try to prevent this, let's say, incorrect stage with state status.
Yeah, well, two things come to mind. So, for that specific example, right? I mean, I would think that if we had a concept of a space, right, there would be limitations of that concept, right? And maybe it would be some sort of scheme that said, like, if you have a categorization of space, then you don't get a material. Or maybe you do get a material, but what does it mean? But as far as the original one, another cross-mentioning thing I can think of is just raw voids, right? If I have a wall and a window, the wall definition does not include the cutout of the window, right? And you can imagine that a direction we would go if we wanted more parametricity is a wall up to a roof,
or one of the shaft we discussed, like having a void to many elements.
Right. So, if we got rid of, if we said, no, sorry, this should be a standalone with no other entities, then we are getting rid of some parametric functionality that exists already, and we could want that more.
Well, do we need any parametricity in IFC? I don't think so, because I see IFC as a publishing, not an editable schema. So, why should we have parametricity? And typically, change body or other things, that parametricity is useful or valuable because the other party won't do the same things with the party who has created the parametricity and intelligence. So the other party won't be doing the same thing. He will be doing different things, and he is a different parametricity, which he creates in his own native model.
Well, I mean, so right now, IFC does have some, right? So we could say, okay, the future of IFC is reference B, right? From now on, all IFC geometry is mesh. I think you get some pushback on that, right? I mean, I think there are people who expect more than that in IFC. So I think, I do, by the way, I do think in all these conversations, we do need to talk about what are the explicit workflows that we're supporting, and what are the explicit workflows that we're not supporting, right? So I think there is a discussion around how editable should IFC data be, either naturally or through jumping through a certain number of hoops. Like you used an example before, if you give me a view rep that's attached to a slab, and I can say, okay, examining this view rep, I can see this could be represented by an extrusion. Then I can perhaps make an extruded object in my system, right? Should I have to do that? Number one. Well, it depends. Is that a workflow we support? So I think that the answer is, I think that the statement IFC is purely publishing and not editable is probably a somewhat controversial statement by itself, but that it does lend itself to the question of what our workflows be.
I don't think that CSG geometry should be removed. That kind of geometry bound parametricity, I think, is okay. And so I'm not proposing that the geometry should be just meshes, definitely not.
Right.
So, but there is higher level of intelligence I'm talking about. You have many objects dependent on each other, and many geometries dependent, and you could parameterize how they behave.
Right, well, again, using the simple example that's there right now, you have a window that curves a wall, right? If we wanted to have every single entity be independent, we'd have to remove that, but we're not. Right?
Actually, would you, because if you're assuming that nobody's making, we're not talking about a native IC, or some other tool actually to be consistent in and of itself is actually modifying those three things. Right?
Well, again, it depends on what our representation is, right? The window wall could contain all the cutout geometry as part of it, right? And that's that. And there's a window, and the window is the window. The question is, and then there's some relationship which we all agree is the window-wall relationship, but the void exists in the wall and not the window, I guess. I'm sure we could work it out, but it is a difference from what we have now.
Well, I think we really have to explore what, like, the way we talked about the whether it was a copy on write, so you're never editing anything, you're actually just making new versions as you push it forward. And the new versions could be based on the fact that you reference, internalize, as in convert to a native format, edited, republished. What you've done is replace the thing that you had 2 steps before, which is hard to wrap your head around, but it's also editing by placements versus editing by editing, which is a weird thing to think about.
Yeah, but I also got that to everybody here, but I mean, I just remember a few discussions with our infrastructure owners, and they would very much disagree to say IFC is just media. And these infrastructure owners are quite important organizations. So maybe we really have to go a little bit back on the purpose of IFC. I'm not saying that one is right or explicitly, but I think we have also quite different expectations of it. I mean, I think we probably all agree that IFC will not be like dynamo changing everything, but I remember that things like having an alignment to drive the pavement geometry is a request from our stakeholders. And I can't say we simply forget about it.
But this goes to,
Yeah.
Can you explain, because I don't feel there's a contradiction in what you're saying and the idea of snapshots.
The point is that there are definitely snapshots for purely archiving purpose, as you see there. And I agree that this is mainly a reference problem. But in a few cases, we try to explain this when we had the discussion between reference design transfer view. In a few workflows in industry, you have a change of responsibilities. Like one architect ends the job, the other takes over, or the engineer ends the job, the construction company takes over. And so you have, in a few cases, you have transitions where you would like to have some kind of takeover of the data to be edited. Not 100%, maybe you take some additional efforts, maybe you try to combine it with some half manual or half automatic processes, but we do have these stages in our workflows. And as an infrastructure owner who tries to contract an engineer maybe for the preliminary design and routing, and then somebody else for the detailing, then maybe somebody else for the construction preparation. It's of their interest that there's some kind of way to hand over information.
But
More than reference.
the way, like, at least it's come up in other discussions as well, what we haven't ever done is thought about, we have examples of work that like John Merchant does, which is nominating geometry to be a thing, to serve a function like this. So like we don't, maybe we do, the alignment is a first class object in IFC today. Okay, so we don't treat any other reference geometry in IFC like that, right? Everything else is right. Like we don't have anything else we directly convert IFC today that, well, they would become components right away. But actually, that's a very logical thing that actually this set of points are components. Their placement location for columns. Just like we have grids, they're become a component. So there's a big gulf between CSG and meshes and parametric, but there's also this place that with this, the point of looking at this component in the component approach is that you can have a point, a curve, a mesh, a solid. Which one do you want to use?
Yeah, I think we're going to need to have both in the following sense, in the sense that geometry primitives have to have an option of being first class entities and also be primitives, right? Because so cloud points it would be ludicrous to have it do it on every point. Yeah, sure. But if you're going to put your fence post on a point, it's got to be a first class entity. It's got to be referenceable. And I think that's probably doable, right? Especially because we're not dealing with this thing. It's baked into the class structure whether or not you're a first class entity or not. If you have a GUID, then you're a first class entity, right? If you're not a first class entity, you do it. So
Thomas, I don't, when I talk about this reference and use, it's closer to the design transfer view than the current MVD, reference MVD of buildingSMART. So I don't mean that it should be dumped down. You have the same information. It's more about how you use it when you get it. Do you block convert it to native or do you consume it in the IFC format? But it has nothing to do with the content. But what I'm saying is that we should remove things which are in IFC for editing it as IFC. That I don't believe in one iota. You always would create some native of it, but the content of the IFC should be the design transfer. Completely. It's just the way of consumption I'm talking about, not the content of the IFC file.
This idea that you go from a reference to a native to a new copy or a new version of the reference in a little loop is a very hard thing to wrap your head around. Well, it looks weird the way we work today because everything today is linear.
That's what's happening now already, but now it's happening more or less haphazard, not kind of in a planned and designed and thought out way. Well, nothing, because nobody, that's very minor that anybody would take, there are some IFC editors that you would edit the actual IFC file and keep it as IFC. Well, that doesn't really happen.
Well, so we should, but the point is, you have pointed out technically that's something reference an IFC, when you make a native object, what you're doing is cloning and referencing back to the IP, which is sort of partial.
No, it becomes a new native.
What is actually how linking IC.
Because that's basic information management, because somebody owns the original IC.
Right, but
And it has a GUI, and there the interpretation is that the GUI is for the virtual object, not for the physical. Because that's a one big problem that I see, that that's not clearly stated anyway. What is the GUI? What is the GUI needed for? And I interpret it so that it's for the virtual object, where you can have many virtual objects representing the same physical object.
What's the schedule for the rest of tomorrow, essentially? Because
so this particular thread, we're done as of today. So the way to wrap this up is, do you want to be a part of this conversation after today? So the best way to do this, I'm going to put my email address up here. This is the dumb way to do it, but if you want to be a part of it, send me an email and when we start, because we basically, David put it the best way. We put a bunch of cards on the table. They look like good cards, but we don't know that they're the cards we should fold or go all in on. And so we have to do that next step. So
That's what standardization is about. It's a consensus.
so let's take it as a hypothetical that this ECS model is something we want to pursue. Maybe we can find out that we were wrong later, but let's take it as a hypothesis. So there are certain pieces of this that need to be nailed down. There are certain experiments that need to be done, right? And I don't know how to say this, but I'm getting lost in the conversation. Probably getting the conversation. We really need to do some drawings and stuff. I mean, we need to get pretty precise in terms of controls. And I think we need to segment what this, so for just off the top of my head, right? By the way, Devin didn't show this, but Devin has done a kind of preliminary ECS model in JSON-LD that I think is super compelling, at least as a starting point. Maybe it's too early to submit that for consensus, but it's an example. There's a lot of questions that need to be tackled, and probably they need to be portioned out to tackle. Like this question about the query template business, right? I mean, that's something, it may need to be resolved in committee, but somebody's got to go take that on, right? So I think, maybe I'm over-engineering this, but I think getting together every month and having these kind of conversations is going to rapidly wind up where we went before, which is just exhaustion. And I think what we need to do is start breaking this thing up and having certain people tackle these. First of all, figure out what the components are, and then starting to have people look at them and actually take certain pieces on.
At least like what short term, at least my instinct is we need to just prototype these things so we can get them in a format that Thomas can review and everybody in the world can review. We take some of these edge cases that we know are going to be hard, and we start with those. Just editing a component, a bunch of components that are properties is super simple, but I think we do have to just test this out. And that's what certainly Leon has suggested as the next step forward in the next number of months is prototype some stuff. But beyond that, I think we have to figure out quicker that we shouldn't, at least my instinct is not to make a big effort before we know it works.
So let me give you an example of one thing that I think where I'm doing with some PhD students is this. We keep talking, I totally agree about this modularization, that the schema needs to be modularized. There's two pieces to that. One is, what is the mechanism that let's say that it's some sort of OWL or JSON-LD, whatever. It's these are chunks of schema. There's three things you need to do. You need to figure out how you develop a chunk of schema, how you take chunks of the parts of the existing IC schema and put them in chunks, and what do you do with these chunks later to sort of demodularize them, right? So we're going to take, and what I learned recently, which I should have known, is if you look at the IFC, and some of this has been done already, but if you look at the IFC documentation, there's a reasonable way that this thing is organized, right? So you can take chunks of this thing and start doing that work. So I think we're going to do that with the whole schema, because that would be a ludicrous place to start. We're going to start with 2 chunks. The building, common elements, and maybe some of the infrastructure, and figure out how to do that, right? So that mechanism for modularizing and demodularizing, we're going to take that on. You know, I don't want to put words in Devin's mouth, but a technical model for expressing this entity component system in something like JSON-LD, that might be something that we could take on, right? So I think maybe a step is to figure out who wants to take on which pieces of this, and just, you know, have people volunteer, but then actually set up a cadence where people are returning stuff, right?
The modularization is not that far from the MVD concept, but it needs to be more strict and rigid, and the aim that there are maybe 10, 20 and not 100.
Yeah, somebody can take that on. I mean, what would be huge is somebody that really understood the schema actually did that and took the pieces and said, okay, here's 10 categories. You know, here's the ones you want in category A, B, C, right? I mean, but anyway, there's a bunch of tasks that are going to move this thing forward, and I think we get to that level pretty quickly, because it will inform these conversations quite a lot. Right? This question about the component, you know, how are components at all? Is there class structure components at all? You know, is that how does that relate to this schema demodularization, right? And what is the mechanism around components, right? I think I'm sorry, in the sense that I think there's something about the content of the schema as they become categories for components that needs to be solved beyond the architecture of what an entity, component, and system work together, right? And then this whole thing about how you develop a query and validation mechanism, I don't understand it at all, and maybe it's Sparkle, and it would be great if somebody took that on.
Maybe one thing we haven't discussed much is the role of systems in the ACS, and because now the big part of the model in a game ACS system is in the systems, because systems specify, define the behavior and what happens with the components. So a big part of the component is in the systems.
Well,
yeah, I still have the feeling that we have to do maybe 2 things in parallel. I mean, having an experiment, like a prototype, is a good thing, and it definitely would also help to get a clearer assessment. Right now, we are speaking very theoretically, I guess, at very different levels of understanding. But the one thing is, I mean, in order to answer the question whether ECS is the right, let's say, paradigm to follow, at first I think we also have to agree on the right questions. And maybe this is maybe something use cases. Yeah, use cases was a question. So what should it be an answer for? And then we can say yes, it is an answer, or no, it's not, or I don't know, the side effects are too big, or.
Well, so this is where I stumble. Like, it's a standard. What are we going to tell people it's not good for?
Yeah, so what are our questions? Maybe it could even be done in parallel. Maybe it could even involve 2 different types of personalities or of persons. But I also would like really to go a little bit. We had this one page, the questions we would like to answer. I think also this needs some more elaboration. Maybe this could be work in parallel, even involving different people.
I mean, I agree. I mean, before we start reworking IFC, it would be good if we had an industry consensus that this is what we're working for, right? Here's our white paper. Here's why we're reworking IFC. Right? Here are the use cases that IFC 5 will be for. Here are the ones that it won't be for. Is there an agreement? Right? Because then infrastructure might come by. You completely missed this, or you know, someone from our region might say, oh, we want full design transfer at all times, or who knows what else, right? Or everyone agrees that no, actually, purely reference is a great thing for IFC 5. I don't know.
Well, just so basically, I don't want to keep going forever. So basically, it's we have a early versions of assembling why we're working on it, like I've done presentations on it, but what you're pointing to is basically formalizing this into something that we can socialize without us in the room having to describe it, basically. And then we do the experimentation process next to that, where we test the bounds of the failure points of this sort of approach versus what we have today, right?
Yeah. There could be alternatives, I don't know, maybe there are others or not. But I think first we have to write out the questions.
Okay, but it's, yeah, I mean, we have a functional list of things that we're sort of loosely solving for, and we know, can we solve design transfer directly? No, but can you do it by this link reference approach, and it's closer to solving it.
I actually don't see why there's any currently supported use cases that this wouldn't support. I think it's all about supporting additional use cases. I can't imagine why you wouldn't be able to transfer model using ECS.
Again, it's just what are we trying to solve, right? And the first group to show this to, by the way, is all the steering committees of all the other rooms, right?
Yeah.
Does this match with what you see as the future of the infrastructure, rail, airport, sustainability, whatever else groups?
But I think what that will say is IFC supports certain use cases today. New use cases are emerging, or it's turned out to be certain things are difficult. We want to support those too.
Yeah, that's fine. As long as we're explicit about it, and
Not
that
ambiguous like we are now.
right.
I think Angel is right. I mean, we need to get a buy-in from all groups on this part. I think it was rough about it.
Yeah, for me, I have some questions in my mind. Is for our next IFC release, is the major purpose to catch up with the current technology which we have to get rid of Express, or are we already at the point where we go into new directions, similar like last century? First, let's say these product models were very based on geometry. A famous representative of this was AP225, which only had, let's say, the living time of a few years when IFC came around, where we understood that the semantics of the model is the core, and geometry just plays let's say, a role, but it's not the dominant role. So it was really seeing from a totally different range. I'm asking myself whether or not we are already now at a point where we still have to rethink how important or dominant the geometry is in the model, and whether the semantic is even more important. So I was not in the room in the debate, but when I listened to this discussion in the past hour or so, still geometry played a major role in the discussion.
Well, so just to catch up, one is we're basically exploring a different system architecture in this ECS concept, which would, I think, we're saying would take a step off the table just because of the data modeling off the table. Step geometry, that's a question. That's one that what we're considering. Two, I mean, you could be of two camps of this. I come from the camp that we can't use this standard because it's not robust enough on the geometry side. And then at the same time, that what you just said makes perfect sense. I come from an architecture firm. It would be good, David, to sort of say yes or no to this. But so if you want a data standard that can sort of chain itself together into an asset, back into a renovation, and sort of make a loop out of itself as life cycle goes, you have to get enough early input into that process. Otherwise, you're just an asset standard, right? So this is the rub of how far do you go with making it useful for complex things, and then can we be smart about using these? Don't try to do direct translation, but link in and relationship-based sort of building up a data set to solve the historically very hard things. I think it's generally what we're trying to sort of negotiate, if that makes sense. If nobody disagrees, then we should just leave. So we should call it a day. Well, so, okay, just 2 tasks we will come away with. One is formalize this into sort of documentation that should help us we're trying to solve for. We socialize with the other rooms, and we come up with a series of small, 1 or more working groups to prototype pieces. And the first question on the prototype side is, we have one, what are the edge cases that we know, like is the sort of the link update sort of question of thing we have to prototype or model out in the system. You know, what's that list? Go from there.
I fully support your approach, your prototype small stuff and then show it. But on the other hand, you already see also with Russell that things are connected, right? The more semantic, the more less explicit shape, you get more editable, etc. It's all connected. So you also need some overall vision, I guess. Of course, we have puzzle pieces, and you might go to Jason, and you might take a paradigm, but they all are related, I guess. So we need an overall, well, we have this roadmap of course. I've not, all this information today, I've not seen the current technical roadmap, I would say. I'm surprised of all these items. So you need a technical roadmap covering that, I guess.
Well, you went to the conversation we had in the technical room, and the reason you haven't seen it is you can make a roadmap generically, but as soon as you actually know what you want to do, which is sort of taking us, we've been working on what does the next version of IFC look like for a number of years. So I actually think we're in a position to actually, like what we're saying, to write down, to socialize with the other rooms is not, maybe not a roadmap, the roadmap much solve forward, right? So this is always been generically, digital twins, yes or no? Yes, right? Mm-hmm. But that's not you can't have a roadmap for yes, right? So I think this is, at least from how you move this forward, and to answer that question, like what does that look like? I think these are actually the steps to do that. I think
By the way, I'm not saying software problems. I'm saying take the hairball, break it up into pieces, and then look at how they start interrelated. There's no other way to develop the system. You can talk about systems, but you can't develop them unless you break them up and then put them back together.
But also at the overall vision.
Yeah, but it's something, and it's, I think everybody should just realize some of the things that, like, ECS is, at least to me, was known in the last year. It's not a term that's common here, so taking the time was actually a useful thing to figure out what to do, at least evaluate another thing. I have yet to see if you had to ask me what the alternative is, I would put my hands up, because it's sort of there is a convergence here. So we're early, we need to test it, but I think, if we do those 2 things, we'll actually sort of be moving in the right direction at least. Okay. Well, I appreciate everyone. This has been a sort of, we looked at text files this morning, and this is the start of the day, and we walked through hierarchies of inheritance and IFC as a starting point, so you're still here, so I appreciate it. Thanks, everybody.